Introduction. We have studied types of numbers such as natural numbers, whole numbers, integers, and rational numbers. In this chapter, we will explore numbers in more detail. Triangular number 3, 6, 10, a square number 4, 9, 16. Objectives. At the end of this lesson, you'll be able to give the general form of two-digit number and its reverse. Give the general form of three-digit number and its reverse. Solve puzzles in general forms of numbers. Check the divisibility of a number by 2, 3, 5, 9 and 10. Numbers in general form. Let us take the number 32 and write it as 32 is equal to 30 plus 2, which is equal to 10 into 3 plus 2. In general, any two-digit number AB made of two digits A and B can be written as AB is equal to 10 into A plus B is equal to 10A plus B. BA is equal to 10 into B plus A is equal to 10B plus A. Let us take 423. This is a three-digit number. It can be written as 423 is equal to 400 plus 20 plus 3 is equal to 100 into 4 plus 10 into 2 plus 1 into 3. 392 is equal to 300 plus 90 plus 2 is equal to 100 into 3 plus 10 into 9 plus 1 into 2. In general, a three-digit number ABC made up of digits can be written as ABC is equal to 100 into A plus 10 into B plus 1 into C is equal to 100A plus 10B plus C. In the same way, CAB is equal to 100C plus 10A plus B. BCA is equal to 100B plus 10C plus A. Games with numbers. 1. Reversing the digits, two-digit number. In general, B2 plus 8A is 177. If we add the two numbers, we get 92 plus 85 is equal to 177. The sum is always a multiple of 11. If we divide the sum by 11, the quotient is BA into B5 is 62A, which is exactly the sum of the digits of chosen number 5 into A. In general, two-digit number A is equal to 0 or A is equal to 5. Reversing digits, we get B as 1. 15 into 15 is equal to 125. B is equal to 2. 25 into 25 is equal to 625. Therefore, A is equal to 5 and B is equal to 2. If one's digit is larger than 10th digit, resulting number is divisible by 9, so the remainder is 0. Reversing the digits, three-digit number. Use this number to form two more three-digit numbers. If you choose the number as ABC, the next number is CAB. One's place goes to hundredths place. The other number is BCA. Tens place goes to hundredths place. Add them and divide it by 37. There is no remainder. 357 plus 735 plus 573 is equal to 1665. 1665 upon 37 is equal to 45 with no remainder. In general, ABC is equal to 100A plus 10B plus C. CAB is equal to 100C plus 10A plus B. BCA is equal to 100B plus 10C plus A. ABC plus CAB plus BCA is equal to 111. A plus B plus C is equal to 37 into 3. A plus B plus C, which is divisible by 37. Letters for digits. Here we are going to use the puzzles based on the problems of addition and multiplication. Let us take the place of digits in an arithmetic sum, and the problem is to find out which letter represents which digit. Rules. Each letter in the puzzle must stand for just one digit. Each digit must be represented by just one letter. The first digit of a number cannot be 0. 65 as 65 and not as 065 or 0065. Example. Find A in the addition. 51A, 1A5 is 703. In the ones column, from A plus 5 we get 3, that is, number whose ones digit is 3. For this to happen, the digit A should be 8. Example. Find A and B in the addition. B2 plus 8A is equal to 177. In the ones column, from 2 plus A, we get 7. This means the value of A should be 5. In the tens column, from B plus 8, we get 17. This means the value of B should be 9. 92 plus 85 is equal to 177. Example. Find the digits A and B. BA into B5 is equal to 62A. One's digit is 5 into A is A, so A is equal to 0 or A is equal to 5. If B is equal to 1, 15 into 15 is equal to 125, but the product should be more than 600. If B is equal to 2, 25 into 25 is equal to 625. A is equal to 5 and B is equal to 2. Divisibility by 10. Consider multiples of 10. They are 10, 20, 30, 40. Non-multiples of 10. They are 23, 31, 42, 55, 69. If the ones digit of a number is 0, then the number is a multiple of 10. If the ones digit is not 0, then the number is not a multiple of 10. Take the number PQR is equal to 100P plus 10Q plus R. P is the ones digit, Q is the tens digit, and R is the hundredths digit. Since 10, 100 are divisible by 10, so are 10Q, 100P. As for the number R is concerned, it must be divisible by 10 if the given number is divisible by 10. This is possible only when R is equal to 0. Divisibility by 5. The multiples of 5 are 5, 10, 15, 20, 25 and so on. In ones place, the digit is either 5 or 0. If the ones digit of a number is 0 or 5, then it is divisible by 5. Let us explain this rule. Any number PQR can be written as is equal to 100P plus 10Q plus R. Since 10, 100 are divisible by 10, so are 10Q, 100P and so on, which in turn are divisible by 5 because 10 is equal to 2 into 5. As far as number r is concerned, it must be divisible by 5 if the number is divisible by 5. So, r has to be either 0 or 5. Divisibility by 2. The even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on. The odd numbers are 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. The natural number is even if its ones digit is 2, 4, 6, 8 or 0. A number is odd if its ones digit is 1, 3, 5, 7 or 9. If the ones digit of a number is 0, 2, 4, 6 or 8, then it is divisible by 2. Any number PQR written as 100p plus 10q plus r, 100p, 10q are divisible by 2 because 100 and 10 are divisible by 2. As far as number r is concerned, it must be divisible by 2 if the number is divisible by 2. So, r has to be 0, 2, 4, 6 or 8, only then the number is divisible by 2. Divisibility by 9 and 3. In the divisibility by 10, 5 and 2, we use only the ones digit of the given number. We do not bother about rest of the digits. The divisibility is decided by the ones digit. For checking divisibility by 9, let us consider 2689 is equal to 2 into 1000 plus 6 into 100 plus 8 into 10 plus 9 is equal to 2 into 999 plus 1 plus 6 into 99 plus 1 plus 8 into 9 plus 1 plus 9 is equal to 2 into 999 plus 6 into 99 plus 8 into 9 plus 9 plus 6 plus 8 plus 2. If 9 plus 6 plus 8 plus 2 is divisible by 9 or 3, then 2689 is divisible by 9 or 3. 1. A number n is divisible by 9 if the sum of its digits is divisible by 9. Otherwise, it is not divisible by 9. 2. A number n is divisible by 3 if the sum of its digits is divisible by 3. Otherwise, it is not divisible by 3. Consider the number PQR. 100p plus 10q plus r is equal to 99p plus 9q plus p plus q plus r, which is equal to 9 into 11p plus q, divisible by 3 and 9, plus p plus q plus r. Divisibility by 9 or 3 is possible if a plus b plus c is divisible by 9 or 3. Example. Check the divisibility of 1, 2, 3, 4, 5, 6, 7, 8 by 9. Solution. The sum of the digits is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, which is 36. This number is divisible by 9. Therefore, 1, 2, 3, 4, 5, 6, 7, 8 is divisible by 9. 1, 2, 3, 4, 5, 6, 7, 8 upon 9 is equal to 1371742. Example. Check the divisibility of 285751 by 9. Solution. The sum of digits 2 plus 8 plus 5 plus 7 plus 5 plus 1 is equal to 28. 28 is not divisible by 9. Therefore, this number is not divisible by 9. Summary. Let us summarize what we have learned. Numbers can be written in general form. Two-digit number can be written as AB is equal to 10A plus B, BA is equal to 10B plus A. Three-digit number can be written as ABC is equal to 100A plus 10B plus C. CAB is equal to 100C plus 10A plus B. BCA is equal to 100B plus 10C plus A. This general form of numbers are useful in solving puzzles and number games. Divisibility by 10. If the ones place of a number is 0, then it is divisible by 10. Divisibility by 5. If the ones digit of a number is 0 or 5, then it is divisible by 5. Divisibility by 2. If the ones digit of a number is 0, 2, 4, 6 or 8, then it is divisible by 2. Divisibility by 9 and 3. If the sum of the digits of a number is divisible by 9 or 3, then it is divisible by 9 or 3.